Example number 2. We've got a few up here. It says simplify the radical. This first one's super easy. Root 2 times root 8. We know we can multiply radicals. So that's going to be root 16. And then, of course, I need to simplify that. The root of 16 is 4. Okay? Mr. C, isn't it positive or negative 4? No. You'll notice that these are the principal square roots. That means that they are the positive ones. Okay? We didn't have that x squared equals 16 and x could be plus or minus 4. We did not have that. We just had root 16. And if there's nothing in front of it, then we assume we want the positive, the principal square root. Easy. All right? Now this next one, Chase, you're going to notice I do it just like I would do it if it's a regular number. Root 2 times 5 is 5 root 2. Root 2 times minus root 3 is minus root 6. There's nothing else I can do, Jordan. Eddie, do you see that root 6 doesn't simplify? I mean, it is root 2 times root 3, but there's no perfect square in there. So I just leave them together. There's nothing that I can do. Okay? Now, you might see if I needed to factor that I could and go back to it. Do you see that this is 5 root 2 minus root 3 times root 2? Both of these terms have a root 2 in them that I could pull out front, and I get root 2 times 5 minus root 3, right? Which is what we've been doing, but that's where I started. That's not what they asked me to do. They said to simplify it, so I just multiplied it out. And this is my answer. Does that make sense? Now, this next thing I want to talk about for just a moment. These two things, these are special. They're called conjugates. I'm going to go back to the first screen here, and you'll see our two terms are rationalize and conjugates. Rationalize means we want to get rid of any radicals that are in the denominator. We never want radicals left in the denominator. That's like having a negative exponent. We always want to get rid of negative exponents. That's like having 6 over 4, a fraction that's not reduced. These are things that we want to get rid of if we need to. Okay? I mean, if we have them. So if you look at this one, I'm sorry, well, you'll see we'll be doing that in just a minute. We'll be rationalizing. But to start with, we're going to have this pair right here. They're called conjugates because the only thing that's different between them is the plus and minus. You'll notice that this is the sum and difference pattern. We know how to multiply these things. We like it because we know that, let's see, Chris, don't we know that this is going to be 2 squared minus root 3 squared? Because that's the sum and difference pattern. It's just the first thing squared minus the second thing squared. And we like that because this gives us 4 and it gets rid of the radical. We get 3. And 4 minus 3 is 1. I don't have to go about multiplying this. I know already that a sum and difference pattern is always going to give me the first thing squared and the second thing squared with a minus in between. We've been doing that now for a few weeks. Okay? And that's good. These things are called conjugates. It makes it easy to get it out of the denominator, to get a radical out of the denominator. Okay? All right. And we're going to see that in the next example. Good job, guys. Example number 3 coming up.